NASA's Deep Space Observing Telescope is looking at the universe like never before. Built as a successor to the venerable Hubble Space Telescope, James Webb Telescope is also breaking ground in scientific excitement. This $10 billion machine now is a pathfinder of scientific discovery, generating incredible insights about galaxies, planets, stars, and all sorts of interesting cosmic objects. People around the world are sharing its images or generating new insights by manipulating raw information. Join us as we bring you all the latest breathtaking images taken by the Webb and find out how it is revealing the secrets of the cosmos. A new image from the James Webb Space Telescope, JWST, shows in stunning detail the wreckage of a cataclysmic supernova explosion. The supernova remnant known as Cassiopeia A or Cass A formed about 340 years ago from our perspective here on Earth. This makes the 10 light-year-wide Cass A one of the youngest clouds of supernova wreckage we know of. With images like this, scientists can perform cosmic forensics to better understand what happens when stars die. Material expelled by supernovas such as this goes on to disperse throughout galaxies and becomes the building blocks for the next generation of stars and planets. Around 4.6 billion years ago, such a process helped forge the Sun and the planets of our own solar system and paved the way for living things, supplying elements like the calcium in our bones and the iron in our blood. Cass A can provide a window to the very early stages of this process, and for this reason, the object located 11,000 light-years from Earth in the constellation Cassiopeia has been widely studied by astronomers with ground and space-based telescopes. Cass A represents our best opportunity to look at the debris field of an exploded star and run a kind of stellar autopsy to understand what type of star was there beforehand and how that star exploded, said Danny Milosavljevic of Purdue University in Indiana, principal investigator of the Webb program that captured the new observations. But few previous observations have shown the complex structure and vivid colors of Cass A to this level of detail. Translating infrared light from Cass A, the wavelengths JWST observes into vibrant colors seen in the new image isn't a purely aesthetic choice. It also reveals a wealth of scientific information that researchers are only just beginning to access. Performing forensics on a dead star at the top of the newly released JWST image and at the outer edge of a bubble of material blown out by the supernova, veils of orange and red represent emissions from warm dust, NASA officials said. This is where material ejected by the exploding star has been driven into surrounding gas and dust, heating it and causing it to glow. Within the bubble and running to its center are bright pink clumpy filaments which represent material from the exploded star. These filaments produce emissions from heavy elements like oxygen, neon and argon, which the doomed star forged via nuclear fusion prior to its destruction. In millions of years, these elements may spread out from Cass A and help form a new stellar population. While the process by which supernovas spread the elements for future stars or planets is well understood by scientists, what isn't as clear is how early galaxies came to be filled with large amounts of cosmic dust. Investigating Cass A with JWST could help solve this mystery. But in the meantime, let's continue to witness breathtaking images of deep space captured by the $10 billion machine. NASA's Webb scores another ringed world with a new image of the solar system's other ice giant, the planet Uranus. The new image features dramatic rings as well as bright features in the planet's atmosphere. The Webb data demonstrates the observatory's unprecedented sensitivity for the faintest dusty rings, which have only ever been imaged by two other facilities, the Voyager 2 spacecraft as it flew past the planet in 1986 and the Keck Observatory with advanced adaptive optics. The seventh planet from the Sun, Uranus, is unique. It rotates on its side at roughly a 90-degree angle from the plane of its orbit, causing extreme seasons. Uranus takes 84 years to orbit the Sun. Currently, it is late spring for the northern pole, which is visible here. In contrast, when Voyager 2 visited Uranus, it was summer at the South Pole. The South Pole is now on the dark side of the planet, out of view and facing the darkness of space. This infrared image from Webb's near-infrared camera combines data from two filters at 1.4 and 3.0 microns, which are shown here in blue and orange respectively. The planet displays a blue hue in the resulting representative color image. When Voyager 2 looked at Uranus, its camera showed an almost featureless blue-green ball. With the infrared wavelengths and extra sensitivity of Webb, we see more detail showing how dynamic the atmosphere of Uranus really is. At the edge of the polar cap lies a bright cloud as well as a few fainter extended features just beyond the cap's edge, and a second very bright cloud is seen at the planet's left limb. Such clouds are typical for Uranus and infrared wavelengths and likely are connected to storm activity. This planet is characterized as an ice giant due to the chemical makeup of its interior. Most of its mass is thought to be a hot dense fluid of icy materials, water, methane and ammonia above a small rocky core. Uranus has 13 known rings and 11 of them are visible in this Webb image. This was only a short 12-minute exposure image of Uranus with just 2 filters. It is just the tip of the iceberg of what Webb can do when observing this mysterious planet. In 2022, the National Academies of Sciences, Engineering, and Medicine identified Uranus science as a priority in its 2023 to 2033 Planetary Science and Astrobiology Decadal Survey. Additional studies of Uranus are happening now and more are planned in Webb's first year of science operations. After all, having said that, the Webb has impressed scientists during the time that it has been gathering data since becoming fully operational in June. But the real fireworks are still to come with major discoveries awaiting us. It's slow going, requiring patience, but the results will be worth it. And then one day, it's going to completely change our understanding of our place in the universe, how the solar system formed and evolved, and how the very first stars and galaxies formed. We've made great headway with the telescope and it's going to do spectacular things. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. And as always, thanks for watching, and we will see you next time. Thank you.